In this video, we're going to learn about the sine and the cosine function. By the end, we'll be able to graph the sine and cosine function without any of the transformations. We're going to be able to determine these characteristics of both functions. We're going to understand that the sine and cosine functions are just horizontal translations of each other, and we'll be able to predict the amplitude and the period of a sinusoidal function given its equation. We're going to start with our sine function, but first we need to fill out this table of values from 0 to 360 degrees. We're going to use our unit circle to help us with this because from our unit circle we already know exact values of sine and cosine for angles between 0 and 360 degrees. So let's start filling this out. At 0 degrees, so right here, the exact value for sine is 0. The sine of 30 degrees is 1 over 2. The sine of 60 degrees is root 3 over 2. And remember, on our unit circle, the sine of an angle is the y-coordinate. So the sine of 90 degrees is 1. The sine of 120 degrees is root 3 over 2. The sine of 150 degrees is 1 over 2. The sine of 180 degrees is 0. And go ahead and complete the rest of this row on your own. And now let's just determine the decimal value for these. So 0 is just 0, 1 over 2 is just 0.5, root 3 divided by 2 is 0.87, we can round that, 1 is just 1, and then you can fill out the rest of the table. So now we're going to use the values that we found in our table to plot the sine graph. So our coordinates are going to be of this form. On our x-axis, we're going to have our angle. So I'm just going to put theta in degrees here. And our y-axis, we're going to have the sine of theta. And we're just going to plot one cycle. That's from 0 to 360 degrees. So on the x-axis, we're going to plot 0 to 60 degrees. And every box, let's go up by 15 degrees. So that means every 2 boxes, we're going to go up by 30. Since the y values go up from 0 to 1 and 0 to negative 1, every box I'm going to make worth 0.2. So this is 0.2, 0.4, and so on. And we're just going to use our table to help us graph this. So the sine of 0 degrees is 0. The sine of 30 degrees is 0.5. The sine of 60 degrees is 0.87, so it will be around here. The sine of 90 degrees is 1. And I want you to follow the table and graph the rest of the points in the cycle. And when you plot all your points, you should get something that looks like this, and we can connect all these points with a curve. And there you have it. This is one cycle of the sine function. And if we were to continue this graph for angles that were greater than 360, we would see this cycle repeat once again because this is a periodic function. And if we were to continue this graph for angles less than 0 degrees, so for negative angles, we would see this cycle repeat in the other direction. And you're going to need to become very familiar with the sine function as well as the cosine function. So you'll need to be able to remember these graphs and graph it very easily, especially when we do transformations and especially when we start doing real-life applications. So I find the best way to remember the sine function is to remember some key points. So that would be our x-intercepts, and our maximum points and our minimum points. We have our x-intercepts at 0, at 180 degrees, and at 360 degrees, and they're at even intervals. The period of one cycle is 360 degrees. Directly in the middle of that cycle, we are at another x-intercept. A way to remember where your maximum value is and where your minimum value is, so in between your first 2 x-intercepts, in between 0 and 180 degrees, right in the middle of that is 90 degrees. And that's where our first maximum value is. That's at 1. And in between the last 2 x-intercepts at the end of your cycle, so between 180 degrees and 360 degrees, right in the middle of that is 207 degrees. and that is where your minimum value is at -1. Using our key points, you can also cut this function into 4 equal parts, and this is going to be really helpful, especially when we start doing our transformations. So if we cut this in half down the middle, at our x-intercept, we can also cut it at our 2 maximum minimums, and right at the end, so now you can see these 4 equal parts. In our first section, we go from an x-intercept to a maximum. In the second section, we go from the maximum to an x-intercept. Third section, x-intercept to our minimum. And in the last section, we go from a minimum to an x-intercept. And I'll do this again once we start transformations, because this is the main way I look at the sine function and also the cosine function when I do my transformations. And now we're going to look at some of the properties of the sine function. So the sine function has a maximum value of 1 when x is 90 degrees. And the sine function has a minimum value of -1 at 270 degrees. The domain of our sine function is that x could be any angle. So x is going to be any real number. And the range are all our possible y values, and we only have y values in between +1 and -1. So that means our y values are going to be any real number such that y is greater or equal to -1, but less than or equal to 1. And we have 3 x-intercepts in one cycle. So the first is at 0 degrees, the second is at 180 degrees, and the third is at 360 degrees. We have one y-intercept, and that's at 0 degrees. The length of one cycle is 360 degrees, so that's the period. The period is 360 degrees. And then I'm just going to skip over to the equation of the axis of the curve. So this is where the axis of the curve is at the x-axis. It's right in the middle between the maximum values and our minimum values. So the equation of the axis of the curve is y equals 0. And then the distance between our maximum value, 1, to our axis of the curve, and our minimum value, -1, to the axis of the curve is 1. So our amplitude for the sine function is 1. And now let's graph this cosine function, but first we need to use our unit circle to fill out this table. So remember, all of our x-coordinates are the cosine of these angles. So the cosine of 0 degrees is just 1. The cosine of 30 degrees is √3/2. The cosine of 60 degrees is 1/2. And you should be able to continue the rest of that row on your own. And once we're done that, we can just use these to approximate our decimal values of cos. So 1 is just 1. √3/2 is 0.87. 1/2 is 0.5. 0 is just 0. And then go ahead and complete the rest of the table. And now that we have the table done, we can start setting up our graph. So remember, on the x-axis, these are our angles theta in degrees, and on the y-axis, this is just cos of theta. And we can just use the same scale as our sine graph. So on the x-axis, every box is going to be 15, so that means every 2 boxes is 30 degrees. And on our y-axis, we'll just go up by 0.2. And now let's just use our table to start plotting our points. So the cosine of 0 degrees is at 1. And this is different from our sine function because the sine of 0 degrees was at 0. So our sine function started at 0, but our cosine function is starting at 1. So the cosine of 30 degrees is at 0.87, so it's around here. The cosine of 60 degrees is at 0.5. The cosine of 90 degrees is at 0. And now go ahead and plot the rest of the points on your own. So I plotted the rest of the points and I drew our curve. And you should notice that this shape is actually very similar to our sine function. Well, it's really the same because if we look at our y values, 1 at 0.87, 0.5, 0, and then it repeats. These were the same y values as the sine of our angles. They just came in a different order. So if we look at our sine graph, it starts at 0 and goes up to our maximum value of 1, goes down to our minimum value of -1, and then goes back up to 0. But our cosine graph, it starts at our maximum value of 1, and then goes down to our minimum value of -1, and then goes back up to our maximum value of 1. So these two graphs, they do have the exact same shape, the exact same y values, but for different x values. And if we look at this, if we look at the sine graph, right at 270 degrees, this is where the sine graph would start at our x-intercept and then goes up to our maximum value. So if we were to continue this graph, we would see the sine graph. And our cosine graph just starts in a different spot. It starts at 1. And we can say that the sine graph and the cosine graph are just horizontal translations of each other. And really, the cosine graph is just a horizontal shift of the sine graph if it shifted to the right 270 degrees. So you'll also need to remember key points in the cosine graph so you can easily graph this. So our key points are our maximum values, our minimum values, and our x-intercepts. Now let's determine some of the properties of the cosine function. So cos x has a maximum value at 1, just like our sine function, but this is when x is at 0 degrees and at 360 degrees. And it has a minimum value of -1, and this is at 180 degrees. So the domain, all our possible x values, is that x can be any angle. So x can be any real number. And our range, all our possible y values, is going to be that y can be any real number such that y has to be greater or equal to -1, but less than or equal to a +1. One cycle of the cosine function has two x-intercepts, and this is at 90 degrees and at 270 degrees. And then it has one y-intercept, and the y-intercept is at 1. And just like our sine function, the length of one cycle in the cosine function is 360 degrees. So our period is 360 degrees. And the equation of the axis of the curve is exactly at the x-axis, just like our sine function. So this is at y equals 0. So that means the distance from our maximum to our axis of the curve and from our minimum to our axis of the curve is 1. So that's our amplitude. Our amplitude is 1. And now we're going to work on some transformations of our sinusoidal functions. Sinusoidal functions are just our sine and our cosine functions. We've already done transformations of functions, so you should already be familiar with a and k and what it does to a function and how it transforms it. The value of a, and this is your number that's in front of your function, this can cause a vertical stretch or compression to your sinusoidal function. And it can also cause a vertical reflection, and this would be a reflection in your x-axis. Now, what's significant about a is that it's also the value of our amplitude. And this is because in any sinusoidal function that's not shifted, our maximum value is 1. And our amplitude of that function is 1. That's the distance between our maximum value and our axis of the curve. And remember, the axis of the curve is at 0. So we're multiplying all of our maximum values by a. So whatever value of a is, that's going to change the amplitude. So for instance, if our a value is 2, we're multiplying 1 by 2, which also increases our amplitude to 2. So for whatever value a is, that is, in fact, our amplitude. Now the value of k, and this is the number that is within the function, it's within your sine or your cosine function. This is going to affect your horizontal stretch or compression, and it also affects a horizontal reflection, and this is a reflection in the y-axis. K affects our x values, and to find our new x values, we would take our original x values and divide all of them by k. So we could do the same thing with our period. Our period for our sinusoidal functions, both sine and cosine, is 360. So we can take 360 and divide by k, and that's going to give us our new period. So in conclusion, just like our transformations that we've done with other functions, A represents the vertical shifts and compressions and the vertical reflections. K represents the horizontal stretches and compressions and a horizontal reflection. But they also have a different meaning in sinusoidal functions. A is your amplitude, and K helps you find your new period. So we can take 360 degrees and divide by K to find our new period. So let's use that to find the amplitude and the period of our new function y equals 2 times the sine of 9x. So in this function, we have an a value of 2, and this is a vertical stretch by a factor of 2. And we have a k value of 9, and this would be a horizontal compression by a factor of 1 over 9. So all of our y values are being multiplied by 2, and all of our x values are being divided by 9. And since our value of a is 2, then this means that our amplitude is also equal to 2. And since our value of k is equal to 9, we can use that to find our new period. So our period is 360 degrees, and we need to divide by k. So we're going to divide by 9, which means that our new period is going to be 40 degrees. So this is the length of one new cycle. So let's try another question. We need to write an equation for the cosine function, and this has an amplitude of 5 and a period of 240 degrees. Our cosine function is y equals cos x, and with transformations, a is in front of our function, and our k value is within our function right in front of x. We're automatically given an amplitude of 5, so that means a is just equal to 5. So we have the value of a in our equation, but we do not have the value of k. What do we know about k? Well, k affects our period. And we know that to find the period is equal to 360 degrees divided by k. Since we're given the new period of our function, we're going to use that and plug it into this equation. So since our period is 240 degrees, that's given to us in our equation, 240 degrees is equal to 360 divided by k. So now we just need to solve for k. So to get k on its own, first we need to multiply everything by k. And then we're going to need to divide by 240. So we need to do 360 degrees divided by 240 degrees. And that means our value for k is just 1.5. And now we can just substitute our new values for a and k into our cosine function, which makes this our new equation.